5,
4,
3,
2,
1,
go.
Hello and welcome to Space Now, the space news podcast from the National Space Centre that goes beyond the headlines. I'm space presenter David Southworth.
And I'm space expert Josh Barker.
Coming up today, an asteroid that's worth $10 trillion. That's the headline from a few months ago when it was revealed that a number of private companies have ambitions to put mining operations onto asteroids. Today we ask, is this feasible? And is it a good idea? But first, space wows. These are big or small stories from the news in the last couple of weeks that have caught our eye. Josh, I think you've got one first.
I have. So just recently, just a couple of days ago, in fact, the next Astronomer Royal was announced for the UK. And these are typically an astronomer. It's been in a role for about 350 years.
Yeah.
And they advise the royal family originally on space and the heavens and figuring out constellations and things like that. Nowadays, it's a bit more of an outreach role to celebrate the science that the UK gets up to and things like that.
Okay, that's already interesting. I was going to ask you what the modern day role is, because I know traditionally it would have literally been the astronomer to the king.
Yeah, the very first one was literally there to sort of figure out what was going on in space. But this is a role that's carried on, like I say, for about 350 years. And just a couple of days ago, Michelle Doherty, a professor from Imperial College in London, was announced as the next one.
And she's the first female Astronomer Royal?
She is, which is, you know, always, it's nice to see and to celebrate, but it's always a bit sad. It's 350 years.
Yeah,
it's the
not
first
before
time. You know, we've had some fantastic female astronomers here in the UK, but Michelle Doherty has claimed that crown and she is now the Astronomer Royal for the foreseeable future.
Yeah, it sort of feels almost a shame that this is newsworthy, isn't it? Why should it be newsworthy that the Astronomer Royal is female? But a big step that the first
It
one.
is, yeah, and I think
one
it's always
there.
nice to concentrate on her achievements as well. So Michelle Doherty is an astronomer who does planetary science.
Mm-hmm.
So she actually made her fame, so to speak, on one of my favourite missions, which is a mission called Cassini-Huygens.
Oh, I love Cassini-Huygens.
Yeah,
yep.
which was a lander to go and investigate Saturn and its moons.
Yeah.
And she actually helped discover water and hydrocarbons, so methane and chemicals like that, on the moon of Enceladus.
Oh, right.
Yeah, so she's doing that. She's also involved in the JUNO mission. So
Yeah.
people at home might have heard of the JUNO mission off to Jupiter. So she's one of the lead investigators on a magnetic field instrument on that actually here in Leicester we've done some work on as well. So she's a very active scientist doing lots of really cool planetary science. But now she's taking this official role as a sort of ambassador across the world internationally of what the UK does, what we're doing great, what we're involved in, and helping us secure involvement in those big international space missions.
Interesting. So kind of an ambassadorial role on top of her day-to-day research. She'll continue with those missions you mentioned.
Exactly right, yeah. It's not a replacement. She doesn't now go and sit in the royal household and just look through a telescope, although I'm sure she'd enjoy that. It's pretty fun. But yeah, she does this alongside her science and alongside the work there and acts, yeah, like an advisor and a representative to sort of keep the royal family involved with what's going on, but also to share and showcase, you know, England and Britain's heritage with the world to celebrate our science that way.
Oh, that's fantastic. And do we know anything about, has she got particular views that are likely to sort of drive the way she undertakes this role? Do we know?
I think she is a big fan of robotic missions and exploiting those. So obviously, well, exactly, you know, human space flight's great and it looks flashy, but it's really tricky. We're quite squishy and difficult. And she's got a real interest in those deep planetary observations, finding out and understanding about how those things are going. So I'm going to assume that that's going to influence some of the direction. But I think generally this is a role that's not set policy, but is, like I say, that showcase, that ambassador, that getting people excited, talking about what's going on and sort of helping represent the UK's science on the international stage.
Fantastic. I mean, it's worked already. We're talking about it.
Exactly.
I know more about the Astronomer Royal than I did. Well, onto my space wow. Now this is becoming a recurring theme. It's an update on NASA and Trump. This week, slightly different from some of the updates I've had to give previously. This is a letter signed by 363 people. They're current and former employees of NASA, including some astronauts. It's called the Voyager Declaration, and it's a letter to the interim administrator, the recently appointed interim administrator of NASA in the wake of the budget.
Yeah, it was going to be Jared Isaacman, and then with all the shake-ups and the changes, that's shifted. And I don't think they have got a...
They don't have a permanent one, so it's interim administrator Duffy it's written to. And this is an open letter, which is why we have the full text of it. Now, this is, they've phrased it, this is employees of NASA. Yep. So they've phrased it very much and very intentionally in the framework of official complaints about NASA.
Right, okay.
So they've quoted NASA's policy documents about openness, about welcoming dissent, welcoming dissenting views, and listening. Kind of the same idea of how a diverse workforce gives you different perspectives. NASA's official documents do welcome a dissenting view. So it's phrased in the formal language of that. It's a formal dissent.
Right.
And they raise a few issues. Their main issues are to do with the reducing influence of NASA. This is, remember, we've talked a few times, the budget cuts proposed by the Trump administration. NASA have confirmed some of the things they're going to be cutting. We've talked about those a few times. But the implication...
I think are people concerned that with this step back and this downsizing of NASA, it's going to reduce their influence on on global space as well as not just their capabilities.
And that's one of the things that's specifically raised. Okay. Most of this is couched in fairly general terms. It doesn't talk about specific missions. But that's absolutely one of them, that NASA's influence and therefore the US influence, both on international missions and just generally in the space sector, will be reduced. They talk about worrying about Earth observation, things like that. So obviously some of these things we've talked previously, there's a hope that private companies will step into the gap. That's probably not the case so much with Earth observation. They talk about the public good provided by NASA and similar agencies around the world. Something that the public sector will provide that private sector companies probably wouldn't. So that's one of their concerns.
That's always one of the big concerns around private companies is you sort of, when we're working on a public behalf, we sort of assume that is in doing work that needs to be done rather than the work that maybe can be used to make some money or to advance some personal goals. Whereas that sometimes, it's not always the case with private companies that they're very selfish.
Rarely, I would say.
That's kind of what a company is designed to do. It's not necessarily through malice. It's more through this is a structure that's designed to forward a particular idea. So whenever things move, it does get a little bit
companies, particularly in the States, remember, do have a statutory obligation to provide profit for their shareholders.
Exactly, yeah.
So they're kind of doing what they're supposed to do. In the ideal world, the public sector fills in those gaps, provides things to enrich all our lives, to provide stuff that the private sector probably wouldn't do. So that's one of the issues. And then one of the other main ones is something to do with, it's called NASA's Technical Authority. This is basically a sort of safety commission within NASA.
This was the one, was this set up after was it Challenger shuttle disaster?
Columbia. So the second of the shuttle disaster, Columbia. This was set up in 2003, following, I think, the inquiry following that disaster. So it's called the Technical Authority, and these people, these signatories of this declaration, feel very strongly that it will reduce the ability of that authority to work in the safety of their employees, of astronauts and so on.
Because that authority, they run essentially all the investigations, don't they? They keep an eye out for avoidable accidents and problems that might arise. So it's very much a safety forward sort of organisation.
Yeah, very much so. So they're concerned about that. And they also talk about elements that Congress has, I'm reading this, Congress has appropriated funding for, that's the official wording, I think, for particular programmes. And so they're also, by implication, querying the legality of these cuts.
I
which
think
is interesting.
That always comes back down to that. We often hear of missions being cancelled, but actually, what it is that there's usually a promise, because of the long-term nature of space, is that, there's often a promise that, for the next 10 years, we're going to give you roughly this much money so that you can get the project over.
Exactly.
And often that cancellation is actually the decision that we're not going to carry that on, which, I can imagine that's...
So the overall framing of this is they're calling on the interim administrator to reject these cuts. Now, I'm not sure what the practicalities of that are. Where do they get their money from if they choose to reject these cuts? They have to have their money from somewhere. Presumably there are mechanisms that can happen. I don't know. We're not experts on that, even though we talk about it all the time. The other thing I wanted to just finish on is I thought this was an interesting touch. They've very much kind of, and I think this ties in with the issue with the Columbia disaster and the technical authority trying to avoid those kind of accidents in the future. They do very much kind of pull on the history of those kind of accidents, because they sign off the letter, we dedicate this letter to, and they list the 17 astronauts that have died on actual NASA missions. So the 3 from the Apollo 1 fire, and then 7 each from the 2 space shuttle disasters. So they're very much kind of really pulling on that legacy to ram home that point. One final thing's interesting. 363 signatories. Half of them are named, half of them are anonymous.
Okay.
Now, they're former and current employees, so I don't know if I suspect the mix is most of the current employees are anonymous. I know they've talked about feeling that the culture of openness is being undermined. They feel a kind of the need for silence. They're worried about their place, their jobs in NASA, so I suspect that's part of that reason. But once again, something to watch for the future. It's interesting that we've got pressure from inside NASA now as well. So on to our main topic of the day, asteroid mining. Now, I said earlier, we've seen headlines saying it's worth $10 trillion, this asteroid we're going to be talking about. But we've seen different figures quoted, haven't we? What's the highest figure you've seen, Josh?
I think the highest I saw was 100,000 quadrillion, which I think is like $1 billion or something ridiculous like that.
10 million times as much, I think, as
something
10
like
trillion.
That, yeah.
I think that's right. So part of the reason for, I think, this discrepancy is we don't really know what's there. We have an idea of what we think is the composition of this asteroid, but we don't really know. We know roughly how big it is.
Yep.
We should say which asteroid we're talking about, actually. The one that's
buried in the lead. That's mysterious.
Keep it secret.
Valuable asteroid.
It's called Psyche, or sometimes known as 16 Psyche. And it orbits in the asteroid belt
between
Mars and Jupiter. So it's quite a long way away from Earth. I think at its closest it gets to us, it's around 250 million kilometres.
That's the number I've seen as well.
So it's quite far away. We think it's mostly made of iron and nickel.
Yeah, I think that's one of the things that's unique about this asteroid is it's a very, very high metallic asteroid. It's got a lot of metal material in fact, to the point where we think it may have been a small planet, similar to Earth or Mars, that in the history of the solar system has been bombarded and had all the rock stripped off the surface and sort of left just this metallic core. We know the Earth's got a metal core, and we think this might be what we're seeing, is this central core across there.
I mean, maybe that's a very interesting point to pick up on briefly before we get on to the worth of it and the feasibility of this. Because NASA are sending a probe there, aren't they? It's confusingly also called the Psyche probe, the same name as the asteroid.
Yes.
To investigate this asteroid. And probably unfortunately for people that are desperate to mine this iron and nickel, they're not aiming to do that, not even really aiming to work out that. They're aiming to work out more about the provenance of this thing and if it can tell us something about the formation of planets.
Yeah, exactly right. So we know that this thing is very heavy. I think it's the heaviest metallic asteroid.
Because it's big, isn't it?
It's big, about 200 kilometres, something like that.
Yeah, 200, 250, something like that.
Yeah, something like that. It's quite large. And we know it's heavy from looking at its motion and how it affects the environment around it. So we know that it's got a lot of metal in. We know from studies of other asteroids and other planetary bodies that it's probably got things like iron and nickel and gold and platinum and
as well as we think some rock. It's not purely
some rock,
metal,
there'll be some rock in there as well. But yeah, figuring out exactly what it is, and that's back to, right at the start, we were talking about how these values vary wildly because we don't really know what the percentages are, exactly how much, and that's what Psyche, the mission, is going to do. So it launched in 2023, I believe, and it'll get there in about 5 or 6 years.
I think it's 2029 it's due to arrive, and then orbit for a couple of years.
Yes, it's going to spend about 2 years there, but it's mainly there, like you say, to study exactly what this asteroid is made of, how it's reacting, how it's changed, to help us understand the science of what it is, why it is, and how it got there.
Yeah, and I think we think it's gone through the process of differentiation where kind of layers of different materials form, because there are 2 big craters on the surface. And I think, I may be wrong about that detail here, but I believe we've seen that there are at least slightly different colours or different brightness, different reflectivity, which suggests different materials as this body, maybe you go a bit deeper into it.
Yeah.
So another thing that would tie in with the way a core of a planet forms, I think.
Yeah, exactly right. And that differentiation is a really important topic. It's the same as what happens to Earth. We talk about, we see these metal asteroids and we talk about how they're great because they're all the metal. And it's like, well, actually, if you look at overall, most of the objects have got roughly the same amount of metal in. It's just that on the Earth, we were so large that when we were forming as a planet, most of our metal sank to the middle. So we've got this big metallic core where all the heavy elements are. And actually, the metals that we extract from the surface to make furniture and cars and all that sort of stuff, those are sort of the traces that were sort of left behind in the outer edge, the vast majority in the middle. So if you could strip all that rock away, like we think happened to Psyche, suddenly you've got a concentrated store of all this material.
So it's interesting from a scientific perspective, but that also means that if we can access that material, it's much easier to access because it's on the surface. So the moon is similar to the Earth in the sense that it has mostly rock, and then inside we think there's iron and stuff like that. But it's too hard to get to it. If we can access this iron that we believe exists on this asteroid, it's right there. There's more for us to get.
That's exactly the hook that have got people's eyes rolling with dollar signs, is that, there's all these resources that if we could extract all the resources from the centre of the Earth, we'd have, so much iron we wouldn't know what to do with. It would be, super cheap because there'd be too much of it and we could just use it freely. If we can go to an asteroid where that's easier, then that's something we can do. We can get much easier access. When you look at the cost of extracting materials from the ground, it's getting there and getting it out that's really challenging. Once you've got it, it's relatively straightforward to then refine it and use it. It's actually that extraction process that adds all the costs and the trickiness that we have. So these asteroids are a bit of a tempting target to get there.
So let's talk a bit about, before we get on to feasibility, how economists have come up with this figure, whatever the figure they decide. How do they decide what it's worth? Because some economics comes into this as well, doesn't there? Because like you said, if we could access all that iron easily on Earth, it would be cheaper.
Yep.
And that would be the same if we can bring all this iron back somehow from this asteroid. We'll flood the market. Supply and demand dictates that if you have loads and loads of supply, something's very, very common, it's not worth as much. So I think there's every chance that these figures would be slightly inflated, slightly exaggerated anyway, if we could access all this iron, because the price of iron would drop.
I think, yeah, it's a really interesting economic puzzle because, yeah, you're quite right. If we just bought that asteroid and stuck it down on surface,
Somehow.
Stuck it in the car park and started chipping bits off, yeah, suddenly the value of all those metals would plummet because there would be so much, available. We could sell it much cheaper than anybody else, and that would drive the prices down. And,
you said an interesting point in there. All these metals, we're not talking about just iron. Iron's probably the cheapest of the metals we think is there. You mentioned nickel, and we think there may be some precious metals in there as well.
We assume, having looked at what we understand about asteroids and meteorites, things like that, we are guessing that that's likely what's there. And some of the evidence we've analysed from the surface, we think show that that's there, but it's the mission that will prove, and we'll know exactly how much of each one. But yeah, you're quite right. These prices will get cheaper, but the big problem is that actually we can't just plonk it in our car park and start chipping bits off. We've got to get there. We talked about the Psyche mission. It's a 7-year mission just to get there, to just take some small science experiments. This is not a giant mission with mining equipment. It's not even thinking about bringing large chunks back safely to the surface of the Earth, and all that adds cost. So knowing what the ultimate price would be, in theory it's appealing because it's suddenly a very easy access to a lot of material, but it's not easy access at all. It's in space. Access, it's 250 million kilometers away.
At its closest.
So it's a very tricky puzzle to try and solve.
So we're talking about asteroid mining as if it's just a thing that's easy. We've talked about the distance makes it tricky, but what are the processes by which we could actually do this? We'd need some infrastructure. Can we just dig this stuff out and bring it home, or are there other ways to do it?
I mean, ultimately, that's what the aim is just dig it up and bring it home. But that's very tricky. Mining takes an enormous amount of heavy materials, machinery. It's often very complex, challenging. It's not, the same. Things can happen. Mine shafts can collapse and rocks can fall and change what you're mining in. So
Bruce Willis can get stranded there.
Exactly. You don't want to be stranding your oil workers up there as well. So there's all these complications. If you go and visit a mine down here on Earth, they are complex, tricky, dangerous, difficult environments. This is why these materials are often expensive. It's not just a case of popping down and picking up a lump of rock off the ground and we've got it and let's refine it.
Although I guess in this asteroid at least you could go from the surface.
It would be easier. But also, we've not got the same gravity that we have down here on Earth.
Yeah, weaker gravity.
You've not got an atmosphere, so you're going to have reactions, you're going to have things moving around. The asteroid itself might not be stable. If you've got, great big piles of loosely shifting rock, that has different complications. So all of those considerations you have when we're doing mining operations on the Earth, yes, you've not got to go quite as deep. Maybe some of that weight of that heavy material is reduced by the fact you've got no gravity, but also the chance of your drill floating off into space is much higher than it is there, or something like that. So there's so many extra complications. You think about the International Space Station. Yeah. That's just 6 people living on a spacecraft.
And it took us 2 years to build it.
It took us 2 years to build it. It takes a huge team of people on the ground to monitor and maintain and keep. And all they're doing, they're doing some experiments. They're doing relatively simple things, but it takes a huge amount of infrastructure to keep that going. Mining is a whole other level of danger, risk, complication.
And you talked about the heavy equipment we need to take. So we're talking about we either need to take astronauts there, and that's certainly not feasible in our current situation of space travel, or we need to automate this. And automating this, that's a huge operation. And we're taking heavy material out there, and we're aiming to bring tons and tons and tons, probably thousands of tons of material back. I don't think on our current technology we can really do that. We don't have the rockets with enough power to get all that stuff out there, bring it back reliably.
No, I think you're quite right. This is not a project that is 5 years out and suddenly we're going to be,
it feels like science fiction.
All having knives and forks made of, moon nickel or whatever. This is a long-term project if we're ever going to solve this.
Yeah.
And it's solving these problems. There's other options about, do we send everything out there to this distance and mine it there? There have been people that said, well, maybe we should try and bring these things closer and have them orbit the Earth and mine them at that point. Solving that problem of getting rid of the distance issue, which adds a whole other issue of moving a giant asteroid close to the Earth, which has a whole heap of complications that I'm sure we'll get into. But it's figuring out how we get there. But this is a long-term project. I think the very first steps in this project sort of took place this year. There's a company called Astroforge, as the name might suggest, are looking to build and make things in space. And asteroid mining is one of their things. And in March of this year, they launched their first small test mission, which was a sample and survey mission. So the idea was it would go out, it would look for targets that could potentially be mining targets, and that would begin that process of once we found a good place, then we can figure out how to mine it. Unfortunately, their mission didn't quite go to plan. They had a small issue when takeoff, and their spacecraft ended up not working. So they have not yet completed that step. But
they're aiming to do that.
They are, and they've got plans to launch another mission next year, and they're still really invested in following this through.
Well, we've talked already about how this feels like a very long-term aspiration. It's not going to happen soon. Talking about that, we've talked mainly about bringing the iron, the raw materials back to Earth. You mentioned another option, which is really feels very sci-fi, of bringing the asteroid to Earth orbit or potentially moon orbit to make it more accessible. I saw another couple of options discussed, which is one is you could process the raw materials in situ. Now that feels harder on an asteroid, a smaller body than maybe say the moon, where you would mine and process things, so what you're bringing back to Earth is not quite as heavy. And another option was in-space manufacturing. So you mine the stuff, you process the stuff, you manufacture what you're going to make. Knives and forks we're talking about. You make all that on a base somewhere on the asteroid. Again, seems unlikely. On the moon, potentially. All of these are starting to really, I've already said, feels a bit sci-fi. That really feels sci-fi, doesn't it?
I think it does, but I think sometimes you have to remember we are living in science fiction.
We've progressed so far. Since the first flight was 1903, and we're now...
Exactly. For the last 20 years, there have been 6 people living pretty much permanently in space. We're not not a week goes by where we don't land a rocket, been in space on a barge floating in the ocean. We're kind of living in sci-fi in some degrees.
I think that's fair.
So I think that's always good to reflect on, is we have come a long way and we are able to do amazing things, even when we've got incredible things to do. But I think that idea of using these materials in place, that's a real big target. So that's something, again, we've been working on. So the Perseverance rover, which is a rover that went off to Mars, that actually tried out some of this. This had an instrument called MOXIE, which was a small experiment that produced oxygen on the surface of Mars.
On a tiny scale.
Tiny scale. But the idea was to show, can we do this? Because if we can produce something like oxygen, well, it means that if we ever send people to Mars, we might not have to take all the oxygen with us.
We could scale that prototype up to make it industrial.
Or we could use it as fuel. We need oxygen to power, rocket fuel. There's also a similar experiment that's being designed around creating things like methane on the surface of Mars, using the materials there. If you can produce methane and oxygen, that's rocket fuel. So suddenly we've turned Mars into a refueling and relaunch station.
If that works, let's move on to, should we do this? What are the downsides? I think we can probably imagine downsides. We talked about bringing asteroids into Earth orbit. That sounds risky to me. If we get that a bit wrong, maybe we're creating a huge impact with the Earth.
That's a very obvious one. That's just a huge
So
risk.
let's move on from that and just talk about potential downsides of actually just chipping apart an asteroid, a space rock. If we were to do that in the asteroid belt, I think it's unlikely to affect us. It's unlikely to cause big problems, even if it went disastrously wrong and debris was strewn all over the place. It's in a debris field anyway. The asteroid is basically a giant debris field. If we did it a bit closer to Earth, there might be bigger issues. But are there any other issues? Are there any problems with either ethically or in terms of the potential impacts on other bodies in space or on the Earth? Are there any others?
I think those are always the things. We never know. Space is a very chaotic environment. We see lovely, sci-fi shows of it being very peaceful and dark and quiet, and occasionally things drift by. But actually, it is a very chaotic system. A small, you lose a small piece of rock and it can go hurtling through the solar system at enormous speeds that could potentially cause damage. And if we accidentally chipped off and lost several 100 tons of material from an asteroid, well, that's going to end up somewhere.
Yes.
Probably going to end up nowhere. Space is quite empty, but does it end up on a collision course with another planet or a spacecraft? And those are risks. And I guess from the point of view, we're constantly thinking about our resource use down here on the Earth. And this adds a really interesting topic of, we use a lot of resources down here on the Earth. That's having a huge effect on our planet. Do we want to go and do that somewhere else? Well, on the one hand, does that mean we have to do less intensive mining down here, and that keeps our landscapes and our species and environments a bit more pristine, but at the risk of another. But if we've got a planetary husk of a core, some would say, well, there's not much happening there, so does it matter if that gets ruined?
We could be pretty certain there's no life there. That's one of the few places
at the moment,
we can be pretty certain.
At the moment, as we understand. So I think, there's an interesting balance of what effect do we have on the environment? Are we going to need resources? Probably. Yeah. We are getting better at recycling and reducing what we use, but
Slowly.
I think that's a slow process, and ultimately we're always going to need inputs, but it's making sure that we do that in a responsible way that I think doesn't add risk, push risk down the line, so it's going to be a problem for future generations. Are we making sure that we're not causing these issues? So I think there are definitely some things around that. There's also the legal requirements over who owns asteroids.
Yeah, I was going to mention the Outer Space
Treaty
was 1967. Is that the right year?
That says you can't own material. So if you mine it, you're not technically allowed to sell it. I think
it says you are allowed to do things if it's for the space industry. You're doing something to the benefit of the space industry. I forget the wording. It's something like that.
So you can use stuff, but it's complicated. And
and if it's private companies making stuff, bringing it back down to Earth, that's probably
I'm making money so I can build a bigger spaceship for everyone. Does that count? I don't know.
Really.
It's a really complicated issue that we are going to have to solve over the next 10, 20 years as we get closer and closer to this being a technology that we can, if we choose to, start to use.
So to wrap up this section, how do we feel about this?
I'm not sure. I think it's something that's inevitable. I do think that as we continue to grow as a species, we do need resources. I just hope that we do this properly, that we do it collaboratively, we work with everybody, and it's done responsibly and sensibly, that we don't cause problems later on. Because I think that's the history that we have.
Absolutely. Well,
and I want to avoid that.
I'm more sceptical than you. First of all, I don't think it's inevitable. I think the technological challenges, you're absolutely right. You corrected me earlier. I'm very negative about these things. It feels like sci-fi. You correctly pointed out, landing on the moon would have felt like sci-fi 10 years before we did it. But to me, this feels really maybe a step too far. I think we're looking hundreds of years away.
Quite possibly.
So first of all, I don't think it's inevitable. And second, I have no belief that it will be done sensibly, responsibly.
I hoped it would. I didn't necessarily think that it was going to be.
So I'm deeply sceptical. It seems to me exactly the kind of thing that ruthless entrepreneurs would exploit for their own ends. The working man would be left behind as ever. I'm definitely deeply more sceptical about this as a concept. I don't like the idea at all. Now, every episode, we want to bring you ways to engage with space for yourselves. And related to this week's asteroid topic, let's talk about the Perseids meteor shower.
Yeah.
First of all, tell us about a meteor shower. What is it? What forms it?
So a meteor shower is when the Earth passes through a trail of debris, so usually left behind by a comet that leaves sort of fragments of rock and behind it in its wake. And as the Earth crashes through, those bits of rock impact in the atmosphere, and we get these delightful meteor shows, shooting stars shooting across the sky, concentrated in a rough period of time. And that's what we've got. So the Perseid meteor shower is the meteor shower that peaks over August. So over the last week or so, you may have caught a glimpse, and you will for a couple more weeks, but it's sort of zenith, its highlight of the peak time to spot things is actually just a few days after this podcast. So if you're watching the day of release, in a couple of days on the 12th and 13th, you should be able to see, or you've got a greater chance of seeing more meteors.
And the Perseids is one of the, we should say a meteor shower is an annual event, these ones, because the Earth's orbit takes you to the same point in space once a year, so it's predictable. It's the same dates every year, and the Perseid meteor shower is one of the most active of the year, isn't it?
Yeah, so you can get up to, I think, highest count, you're getting up to 100, 120 meteors per hour.
Yeah, which is huge.
Like you say, it's one of the, I think it's the second most active of the ones that we see down here.
And lasts a long time. It started mid-July and goes right through, I think, to the, maybe not the very end of August, but close to the end of August.
Yeah, we always talk about them sort of happening almost on 1 or 2 days, which is the peak. That's the best chance of seeing them. But yeah, they've been active for a while, and anybody that's been out and doing a bit of night sky observing may well have seen some meteors happening up above them.
Yeah, it's actually quite handy this year as well, because the peak is quite close to the full moon. So that means there's a bit more light pollution from the moon in the sky. So actually maybe a week or so later might actually even work better for the chance to see them. Yeah,
obviously the moon will stop you being able to see some of the fainter ones, but you should hopefully catch a glimpse of a couple of big ones.
Yeah. So if you do want to get involved in that, what you should do is head out to a nice dark place, try and get away from light pollution, away from towns and cities. Around sort of midnight to 2-3 a.m. is your best bet if you can stay up that late. And have a look up in the sky. Perseus is a constellation from which they seem to start, hence the name, the Perseids. It's close to Cassiopeia. That's an easy constellation to spot, that W of 5 stars up in the sky. So if you can find Cassiopeia, you can find Perseus from there, and good luck finding them. Well, that brings us to the end of Space Now for today. Thank you, Josh.
Thank you.
We're now on a new fortnightly schedule, so we'll see you in 2 weeks for our next episode. That's going to be Ed and Dara talking all about moon conspiracies. Could be a lot of fun. So make sure you're subscribed wherever you're listening. Hit the notification bell if you're watching on YouTube to make sure you never miss an episode. And why not send this episode to the person you would want to mine an asteroid with? Who's going to be Ben Affleck to your Bruce Willis?
And as always, we want to know what you want to know. We've got another mailbag question episode coming up very soon. So if you've got your space questions that you want answered, send them in to podcasts@spacecentre.co.uk, and maybe you'll get to feature in an upcoming episode. See you soon.